What is thermal conductivity and heat transfer? Have you ever wondered how heat travels through different materials? This brings us to the concept of thermal conductivity. So, what exactly is thermal conductivity in the context of heat transfer? Let's break it down. Thermal conductivity is a property that tells us how well a material can conduct or transfer heat. It measures how easily heat energy moves through a substance when there is a difference in temperature. This property is represented by the symbol K and is measured in units of watts per meter Kelvin. In the world of heat transfer, thermal conductivity plays a vital role in conduction, one of the three main mechanisms of heat transfer. The other two are convection and radiation. Conduction is the process where heat moves through a material without the material itself changing position. This happens because of the random movement and interaction of molecules and atoms within the material. The rate at which heat transfers through conduction is directly related to the thermal conductivity of the material. If a material has high thermal conductivity, heat flows through it quickly. Conversely, materials with low thermal conductivity resist heat flow and act as insulators. To understand this relationship better, we can look at Fourier's law of heat conduction. This law states that the heat flux, which is the amount of heat transferred per unit area per unit time, is proportional to the negative temperature gradient multiplied by the thermal conductivity. In simpler terms, heat moves from hotter areas to cooler areas, and thermal conductivity determines how easily this movement occurs. The formula for this relationship is heat flux equals negative K times the temperature gradient. Here, heat flux is measured in watts per square meter, thermal conductivity in watts per meter Kelvin, and the temperature gradient is the change in temperature over a distance. Different materials have different thermal conductivities. For instance, metals like copper and aluminum have high thermal conductivity, making them excellent heat conductors. That's why they are often used in heat sinks and cooking utensils. On the other hand, materials like wood, plastic, and air have low thermal conductivity, making them good insulators that help reduce heat loss. Understanding thermal conductivity is essential for designing systems where controlling heat flow is important. This includes applications in building insulation, cooling electronic devices, and managing heat in engines and industrial processes. In essence, thermal conductivity is a key property that influences how effectively a material can transfer heat through conduction. This concept is fundamental in the study of heat transfer principles in thermodynamics.